So we're now going to show that cos3 theta is equivalent to 4 cos cubed theta minus 3 cos theta. So we're going from a triple angle down to these single angles. If you watched the previous video where we did something similar with sine 3 theta in terms of sine theta, it's a very similar technique. We're going to use a lot of the same identities. So the identities we're going to require, so we're going to start off with this very classic one, cos squared theta plus sine squared theta equals 1. So you use that so much during A-level maths, and we're going to need this one. We're also going to need the compound angle for cos. So this is cos of A plus B is equal to cos A cos B, with a subtraction in this one, minus sine A sine B. So this is the compound angle for cos. We're also going to require some double angles. Now there's only one option for sine 2 theta, which is this nice one, 2 sine theta cos theta. And we're going to require a double angle for cos. Now because cos A plus B up here is written now, I'm going to just prove it. So if we imagine cos 2 theta, so effectively in this compound angle, A is theta and B is theta. So effectively all of these are just theta. What we're going to end up with is cos theta times cos theta, which is cos squared theta, subtract sine theta times sine theta, which is sine squared theta. So we have an identity for cos 2 theta. Now what we're trying to prove is something completely in terms of cos theta. So there's a version of this that we want to use, and the way that we can find it is by replacing this sine squared using the first one. So sine squared theta is equal to 1 minus cos squared theta, and then we get through to cos squared theta minus 1, and then minus the cos squared theta means we get 2 cos squared theta, subtract 1, and this is the one that we want to be using. So we've got these identities, so I'm just going to shrink these a little bit, and then we're going to use them to do the proof. So our first mission is going to be to write cos 3 theta is equivalent to cos 2 theta plus theta. So it's a very novel idea. 2 theta plus theta is 3 theta. Once we've done that, that means we can now, if we assign 2 theta to be our A and theta to be our B in the compound angle, this will now expand out. So we're going to get cos 2 theta multiplied by cos theta, subtract sine 2 theta multiplied by sine theta. Now we can bring in the identity, so we're going to use, as we said, 2 cos squared theta minus 1. It's going to be multiplied by cos theta, so we've replaced cos 2 theta with that one, and then we're going to replace sine 2 theta with sine theta, 2 sine theta cos theta, multiplied by sine theta. So we've put in our double angles. Now we can multiply out some brackets, so we're going to get 2 cos cubed theta minus cos theta, and here we're going to get minus 2 sine theta times sine theta is sine squared theta cos theta. Now you can see here we've now got a cos cubed coming through, so that's nice. So we're getting closer. The only thing is we have this 2 sine squared theta here. So if we want to replace that sine squared theta, we can then use that first identity. We've already had a bit of practice with that, so we know that using this one, we know that we could say that sine squared theta is equal to 1 minus cos squared theta. So our next line, so we're going to get 2 cos cubed theta minus cos theta minus 2, and we've got open brackets, 1 minus cos squared theta multiplied by cos theta. Now you've got to be careful with your negatives here. I always think that actually weirdly the cos one is slightly more difficult than the sine one, just because the double negatives are a little bit trickier. So looking through this, so you've got -2 multiplied by 1 multiplied by cos theta. So that's going to give you -2 cos theta. Then you've got -2 times by negative cos squared theta, which makes it positive, and then multiplied by cos theta again. So we're going to get plus 2 cos cubed theta. And then bring it all together. So you've got 2 cos cubed plus 2 cos cubed gives you 4 cos cubed theta. And then minus cos theta minus 2 cos theta, we get -3 cos theta. And then we have thus shown what we were trying to show up here. And so if you were required to express cos3 theta in terms of single cos thetas, we do it this way. So it's nice because you're using double angles, compound angles, and that cos squared plus sine squared theta equals 1.